Industrial control systems are not one thing. They are 5 distinct levels, each with its own equipment and its own protocols. The Purdue model organizes these levels into a standard hierarchy. It originated at Purdue University and is now the reference framework used across the industrial automation industry. Once you understand it, you can orient yourself in any industrial facility in the world. This diagram shows the 5 levels of the Purdue model. At the bottom is the physical process. At the top is the enterprise IT network. The levels in between are where control happens. As you work through each level, refer back to this diagram. Level 0 is the real world. Motors, pumps, valves, sensors, and actuators that physically interact with the process. This is where chlorine enters the water, where fuel burns in the boiler, where the conveyor moves the product. Everything in the levels above exists to monitor and control what happens here. Level 0 does not compute anything. It acts. Level 1 is the first digital layer. PLCs, programmable logic controllers, sit here. They read sensor data from level 0 and send control signals back. A PLC executes logic. If tank pressure exceeds 90 psi, close valve V12. That logic runs in milliseconds, continuously, without a human in the loop. Level 1 is what makes automated control possible. Level 2 is where operators interact with the system. HMI, human-machine interface, screens display the live process. SCADA, supervisory control and data acquisition software, supervises multiple sites from a single location. An operator at this level sets a pump to run or raises a temperature set point. The PLC at level 1 executes the command. Level 2 handles supervision. Level 1 handles execution. Level 3 covers site operations, engineering workstations, data historians, software that logs process values over time, and manufacturing execution systems. Level 4 is enterprise IT, corporate networks, ERP systems, email, and analytics. The higher you go, the less real-time the systems become. Levels 3 and 4 are often discussed together because they share the most important boundary in an ICS. Below it is the OT world. Above it is the IT world. The Purdue model separates systems by function and criticality. A change at level 0 or level 1 has immediate physical consequences. Level 4 changes affect business systems, not physical processes. Keeping these levels separate is an engineering requirement. Safety-critical control systems need to be isolated from business network traffic. That isolation is not a preference. It is what keeps a running process stable. You now have the map. When someone says the HMI is at level 2, you know what that means. When someone says the level 3 to level 4 boundary is the critical line in any ICS, you know why. The Purdue model is not just an academic diagram. It is the reference structure for every industrial facility you will encounter. That structure is now yours. This lecture is part of the free Introduction to Industrial Control Systems course. 25 lectures, no cost, link in the description.